Hi, in this video, I will review some examples of the fundamental counting rule. We begin with this first problem. It states a code word is made up of a lowercase letter, A or B, followed by 3 uppercase letters, and then 4 digits. Remember that there are 26 letters in the English alphabet. So an example of this password looks as follows. You have a lowercase letter, either A or B, followed by 3 uppercase letters and 4 digits. So we want to apply the fundamental counting rule to compute the total possible code words when the uppercase letters are not allowed to repeat. So to work this out, we start with the lowercase letter. We have to list a number of options. There are 2 options, A or B. Now, remember the uppercase letters, there's 3 of them. They're not allowed to repeat. We start with 26 because there's 26 letters in the alphabet. Once we choose one of those 26 letters, we cannot choose them again. So the next uppercase letter, we only have 25 options and then 24 options for the third. Now, the last 4 characters are digits. There's 10 digits. The digits are the numbers 0 through 9. So there's 10 digits, and digits are allowed to repeat. So we have 10 options, 10 options, 10 options, 10 options. We multiply this out. The answer is 312 million different passwords. Now, in the next example, it states only the digits are not allowed to repeat. So it's the same problem, but now only the digits cannot repeat. So once again, for the lowercase letter, we have 2 options, A or B. Now for the uppercase letters, we can reuse letters. So we have 26 options for each of those 3 uppercase letters. It's the digits that are not allowed to repeat. So we start with 10 options for the first digit. We can't reuse that option. So now we have 9 options, 8 and 7. We multiply this out to get 177,166,080 different passwords. The second problem states the following. A math teacher is getting ready for class. He has 10 shirts to choose from, 8 pairs of pants, 20 pairs of matching socks, 4 types of shoes. He also has 2 jackets that he can wear. If he doesn't care about color coordination, after all, he is a math teacher, how many outfits are possible if he forgoes the jackets? Forgoes the jackets means he's not going to use the jackets in his outfit. So we have 10 shirts times 8 pairs of pants times 20 pairs of socks times 4 shoe types. Multiply that out. There's 6,400 different outfits. For the third problem, it states a talent show is going to be held. There are 3 bands and 2 comics. How many shows are possible for the following conditions? The comics must play between the bands. So we have 5 different acts. The first act will have to be a band. So there's 3 choices for the band. The second act has to be a comic because the comics play between the bands. The third act is a band, so we already chose 1 band. They can't replay again, so there's only 2 options. And since we only have 2 comics, there's only 1 option for the second comic, and finally 1 option for the last band. Multiply that out, there's 12 performances that are possible. Now for part B, any performer, there's no restrictions on who could play first, second, third, and so on. So that means we have a combination of 3 and 2, so there's 5 different acts. So we have 5 acts for the first spot. We can't reuse that act again, so we have to have 4 options for the second act, 3 options for the third act, and so on. This is the same as the mathematical rule of 5 factorial. meaning that we just multiply 5, 4, 3, 2, 1 to get 120 different performances. Thanks for watching this video.